Okay, good afternoon everyone. So this time we'll tackle about statistics and probability. We have here the topic hypothesis testing. So this topic actually comprises on hypothesis testing for the population mean and the population proportion. So what is the content of this presentation would be problems on hypothesis testing concerning population mean. Okay, so we have problems and solutions. So let us have here the first problem, problem one. A manufacturer of a certain brand of wristwatch claims that the mean life expectancy of the battery of the watch is 48 months. So that is actually the claim, no, of the manufacturer. A researcher wants to validate this claim, so he chose a sample of 64 watches and noted that their mean life expectancy is 45 months. Then we also have here the standard deviation of 2 months. Okay, so we have here level of significance 0.05 level. Can you conclude that the mean life expectancy is less than 48 months? Okay, so as what we observe in this problem, that there is what we call as claim, that the mean life expectancy of this watch would be 48 months. So the researcher wanted to validate in this claim. So he chose what 64 watches. Then he obtained a 45 months as the mean life expectancy of those watches with a standard deviation of 2. So as we observe also in this type of problem, okay, this one is directional because there are actually two type of tests. We have directional and non-directional test. Okay, so for the directional test, of course, there is what we call as keywords that would help us to identify if this type of problem is directional. Like for example, if in the last statement, if there is the word above, more, less, below, those are what we call as non-directional, directional test. Then for the non-directional test, of course, opposite to directional, wherein there is no word like above, below, or more or less. Okay. So for directional test, of course, we are not going to divide the level of significance by 2, but we consider that one as our actual area as we are going to get the t value or z value. Okay. So we have here step number 1. We are asked to identify or state the hypothesis. So we have here the first one, the null hypothesis. We have the population mean is equal to 48. That 48 is referring to the number of months. The second, the alternative hypothesis. So that one is actually why do we use less than? Because accordingly in the last statement that can you conclude that the mean life expectancy is less than 48 months? So that's why we use less than. Okay. Then for step number 2, this is now the time that we're going to identify our critical region. So of course, we have here reject the null hypothesis if the computed z value is less than 1.65. So by the way, in this type of problem actually is we will have to use z-test. Okay? Z-test because as we observe from the sample, it is more than 30. Okay? So from 30 and above, we have to use z-test. But for below 30, so we will have to use t-test. Okay? Then we obtain a value of less than, no? Accordingly, we will have to reject the null hypothesis if the value that we obtain from step number 3 is less than 1.65. This 1.65 is actually having an area of 0.05, no, as our level of significance. So we obtain that one from the Z table. Okay, so we have here the Z table. Since our level of significance is 0.05, it corresponds to a z value of 1.65. So we have here the table that illustrates on how we obtain 1.65 as our z value with an area of 0.05. Okay? So we have here the horizontal and the vertical arrows. So as what we observe, Before that arrow actually, from the horizontal, we found out that there is a value 0.05050. But that value exceeds, no? Lapas siya sa 0.05. So we'll have to look another value before on it, no? So we have 0.04947 as our corresponding value, or approximately equal to 0.05, because when you are going to round off that one, it would become, or it will become 0.05. Then of course from the left hand side, okay, sa iyang tail we have negative 1.6, or we will have to use only positive, which is 1.6. Then from the vertical line or arrow, we have here 0.05 as its unit. So if we're going to add 1.6 plus 0.05, we have 1.65 as the result. And that would serve us as our z value. Okay? So we have here an illustration. 1.6 plus 0.05 is 1.65, because 0.05 is approximately equal to 0.04947. Okay, so let us have now step number 3. We are now about to compute the test statistics. So, of course, the type of test that we're going to apply in this problem is z-test. As I mentioned a while ago that we will use z-test because as we observe in the sample, it is more than 30. Okay, from the problem actually, we identified that our 45 is will corresponds to the mean from the sample. Then 48 is referring to the mean from the whole or the population. Okay. Then our standard deviation, we have 2 or 2 months. Then over square root of n, which is referring to our sample size, and that is equal to 64. Using our scientific calculator, we obtain a value corresponding to z. We have negative 12. Okay? So we have the value negative 12. So this is now our basis in which we can, of course, decide whether we are going to accept or reject our null hypothesis. Uh, what value that we're going to compare in this one? So we have to compare this value negative 12 from our critical region. Okay, so this is now the time for step number 4. Okay, so we have to make the decision. Okay, so we have, of course, reject the null hypothesis since the computed z value of negative 12 now from this one, step number 3, is less than the tabular value of, we have 1.65, okay, that is actually less than man, no? Because accordingly from our first step, or the second step, that we will have to reject the null hypothesis if the computed z value is less than 1.65. Then we have here, we obtain a value of negative 12, and of course, it is less than 1.65. So that's why we rejected the null hypothesis. And conclude that the mean life expectancy of wristwatch is less than 48 months. Okay? We have here problem number 2. Recent survey stated that Filipinos send an average of 1,500 text messages per month. To verify this claim, a researcher surveyed 25 Filipinos at random and found out that the average number of text messages we send per month is 1,486 with a standard deviation of 54. Okay? At 0.06 at 0.05 level of significance, is there enough evidence to support the survey's claim? Okay? So in this type of problem, of course, this one is referring to non-directional test. Okay, so because there is no keyword in here that would help us identify for directional test. Like for example, uh, above, below, less or more. So those are the words that we are going to identify from the problem if it is directional. Since this one or this type of problem is directional, non-directional rather, this is now the time that we have to divide the 0.05 by 2 as our level of significance, no? because we are going to get the critical region from both sides of what the bell shape, the negative and the positive value for z-test. For t-test. We will use t-test in this type of problem because our sample is of course less than 30, which is 25. Okay, so we have here step number 1, state the hypothesis. Our null hypothesis, of course, equal to 1,500 as stated in the problem, or it is serve as the claim. No? Then our alternative hypothesis against the null hypothesis, we have our population mean is not equal to 1,500. Okay? Step number 2, this is now the time that we will have to identify the critical region. Then for us to identify also the critical region, let us have also identify df, or referring to the degrees of freedom, which is equal to n minus 1. And in the problem, our n is 25, so we have 25 minus 1 is 24. And this 24 as our degrees of freedom, we will pair that one to the level of significance, which is 0.05, after dividing it by 2. So we have 0.05 divided by 2 is equal to 0.025. Okay, so the reason why we divided 0.05 by 2 because this type of problem is non-directional test. So we have here a pair of values, 24 and 0.025, that would help us identify our critical region from the t-test table. Then reject the null hypothesis if the computed z-value is less than negative 2.14. Okay, and greater than 2.14. So as what we observe, we get the value, or we use the values negative and positive because that is non-directional test. Okay, so for this one, we have here an illustration on how we get the value, which is plus minus 2.06. Okay, so our degrees of freedom, of course, is 24. Then we have our 0.025 after we divide 0.05 by 2. Then we have here the intersection of 2.06390, or approximately that is equal to 2.06. So we have here our critical value plus minus 2.06. Then for step number 3, this is now the time that we will compute the test statistic. Of course, the type of statistic that we are going to apply now in this second problem is t-test, okay? Because n is less than 30. So we have here the formula. T is equal to x bar minus population mean over s. That s is referring to the standard deviation over n, which is referring to the sample size. Okay, from the problem, we identify that our sample mean is 1,486 minus 1,500 as our population mean over 54, referring to our standard deviation, and 25, or square root of 25, which is our sample size. Using our scientific calculator, we obtain a value of negative 1.30 approximately. No? Then this value, we can actually now decide whether we are going to reject or accept the null hypothesis, okay, based on our critical region from step number 2. Okay, so we have here our decision. Since our computed p-value is negative 1.30, so we fail to reject the null hypothesis since the computed p-value of negative 1.30 is within the tabular value of negative 2.06, and we have positive 2.06. So negative 1.30 is at the middle between of negative 2.06 and 2.06. Therefore, Filipinos sent an average of 1,500 text messages per month. Okay? Okay, so I hope that this example will help you, particularly in answering your activity similar to these examples. Thank you and God bless.